So, Assalamualaikum once again, class. So, in our last two videos, we have talked about bearing stress at saka examples ng bearing stress. Well, this time, ang pag-uusapan natin is about a thin-walled pressure vessels. Okay? Again, thin-walled pressure vessels. So, ano nga bang thin-walled pressure vessel? So, it is a tank or a pipe carrying a fluid under a pressure which is subjected to tensile forces which resist bursting, developed across longitudinal and transverse sections. So basically this time, yung pag-uusapan natin is about tank or pipe or vessels, kahit ano dun, that in which it can withstand or kaya nitong labanan yung bursting or yung pag-explode. When there is this force or pressure, kapag pressurized, yung tank na yun, kapag may tubig, means may tubig or may gas. Because fluid is both liquid or gas. Okay? So meaning to say, we are talking about the strength, yung lakas ng isang pipe, considering may pressure ito, okay? In which it will not burst. Meaning to say, di ba ito? Developed across longitudinal and transverse sections. Ang ibig sabihin dyan sa developed across longitudinal is kapag, for example, ito is yung pipe. Ang ibig sabihin sa longitudinal is, hindi siya mai-elongate o di ka gamit. Kasi nawas magamit ka na subra na kaputol so pipe. Next, transverse sections, meaning to say, nagiya circumferential yan, giya kategoro yan. Adis kaya ng bato. Kapag pressurized na di kong batos na yan, okay? Yan yung pag-usapan natin. Yung lakas or kung gaano kalakas yung isang pipe o isang tank na hindi siya mag-burst, meaning di explode or di break. Okay? So that is all we will be talking about in this topic or lecture. So obviously, there are two types of stresses that the vessel feels. Those are actually tangential stress or circumferential stress, and second is longitudinal stress. Meaning to say, nasa ko sa vessel or sa tank, na duwa ko na stress at kagdan yan. Those are the tangential at saka longitudinal stress. Because take note, sa strength of materials, ang pag-uusapan natin is yung lakas ng isang material despite of the presence of stress or force or pressure. Okay? So, first, let's consider tangential stress or circumferential stress. Consider the tank being subjected to internal force, pressure P, meaning to synergia. Pressure P, the length of the tank is L, giya mo na length L, and the wall thickness, so kakapalian na T, isolating the right half of the tank. So, to give you the clearer vision of kung ano yung pinagsasabi ko dito, let's consider this board, okay? Okay. First, ang pag-uusapan natin is tangential stress. Ano nga ba yung tangential stress? Basically, tangential stress can also be called as circumferential stress, okay? Circumferential stress means to say saya sa circumference. Okay? So now, assuming this is again a pipe or this is a tank. So tangential stress, there is this, consider this tank na may diameter D, may thickness na T. Okay? Yung sabi natin kanina sa definition, pressurized by a fluid, meaning to say gas or liquid. Assuming this is the tank, is kanyan, it has an internal pressure. May internal pressure siya dito na P. Okay? Giyatang na naka-pressurize ka yan. Ang internal pressure yan sa P. Okay? Giyasaya po na internal pressure yan sa P. Okay? So next, let's isolate. Meaning to say na, ipagkatano giya tank sa center. Para makita natin yung behavior ng tank na ito. Okay? Ng material. Para makita natin yung behavior ng material when there is this pressure inside that tank. So, here, isolate natin yung ikat natin. Ang mangyayari is this one. Okay? Itong dito. So, may length na L, ito. May diameter D na ito. Tapos may thickness. Okay? Get the illustration? Because sometimes, sa strength materials, para mas maintindihan yung isang problem or kung ano yung ina-analyze natin, para maintindihan ito dapat is, we know how to imagine things. We know how to illustrate things in our mind. Okay? Kasi imagine kung dito lang, pwede hindi dito ma-imagine. Okay? So that's why we have provided in illustration of those figures. So, consider that one. First, di ba may pressure ito? And the formula ng pressure is, di ba, pressure is equal to force over area, right? Yan yung formula ng pressure. But take note, force, if cross multiply natin, force is equal to pressure times area. So force is equal to force times pressure times area. Di ba natin yung pressure? If i-isolate natin ito, ang mangyayari, ang magiging illustration yan is, nandito yung force. Okay? Ito yung mangyayari sa force natin. Of course, since this is our force, yung magiging cross-sectional area niya, meaning to say, so area affected is the perpendicular area. This one. Okay? So ano yung perpendicular area? Obviously, perpendicular area natin is the, so force equal to pressure times the diameter times the length. Imagine ito? Again, katayaw sa force. Ayan yan perpendicular area na diameter times the length. Okay? So yun. Next. Yun. Na-consider na natin yung behavior ng tank na ito because of pressure. Now, titignan natin is behavior ng tank because of stress. Diba, formula ng stress natin, last time na-discuss natin sa prelim. Normal stress is equal to force over area. Same din dito. This time, tangential stress is equal to, before that, tingnan muna natin ito. Diba, sa mechanics of statics ninyo, I don't know if na-discuss ninyo, na kapag yung isang bagay ay nag-add sa certain part, sa certain section, it creates reactions, right? Example, ito, simple beam. For example, this simple beam, okay? May hinge at saka may roller. Di ba sa simple beam na yan, may reaction dito, reaction sa X at Y for hinge, tapos may reaction for roller, right? Assume natin, i-cut natin dito, okay? We have cut that beam. Tapos, draw natin ulit yung FBB in a cut section. As you can see, may reaction dito, may reaction dyan. Yung reactions dito, ito, this one, and this one, are all what we call internal forces. Kapag nag-cut tayo sa isang section, it creates forces as well. This time, yung cut section na yan, yung reaction or yung force inside a member or inside the body, yan yung tinatawag nating internal force. Consider natin. Here's the point. Consider natin yung tank na yan. Yung tank na ito. I-cut natin dito. Ito, right? I-cut natin siya ito. Meaning to say, since nag-cut tayo, magkakaroon din yan ng same dito, reaction. Okay? Reaction T. We denote this one as T as the tensile force. Gets ito? Tensile force. So meaning to say, stress is equal to force, which is T, over L. Okay? Force, tangential stress is equal to tensile force over L. Bakit ito yung ginawa natin force? Kasi this time, i-analyze natin is yung behavior ng material na ito because of stress or because of this force. Okay? So, let's see. Cross multiply. T is equal to sigma T times L. Times area. Okay? Area. Pero, ano nga ba yung area pagdating sa force na ito? Of course, yung force na ito, yung perpendicular area is, sa force na yan, perpendicular area natin is yung thickness times the length. Gets? Diba kanina, nandito yung force natin, yung force F. Pero this time, due to stress, yung tensile force natin is nandito sa side na ito. Itong dito, okay? So meaning to say, yung area niya is yung thickness ng vessel at saka yung haba nito, yung length nito. Okay? That's why T is equal to sigma T times L. Thickness times L. Okay? Now, tingnan natin yung summation of forces at x. Okay? Summation of forces at x is 0. Right? So isang F is equal to dalawang T. May guess ito? F is equal to dalawang T. Summation of forces at x is equal to 0. Tapos F is equal to 2T. Klaro ba? Okay, klaro. So, since may values or may value yung F natin, so natin substitute natin dito. F is equal to P dl equals to 2 times yung T natin, which is sigma T thickness times L, right? Tapos, hanapin natin yung formula ng T. Okay, divide both sides natin ng 2dl. So, P dl over 2dl. Yan yung answer, yan yung na-derive natin. Since may L sa taas, may L sa baba, cancel natin. Ang matitira lang is PD over 2T. So, as you can see in your handouts, yan yung formula ng tangential stress, right? So, the point is, in this video, i-introduce ko sa inyo kung paano yung derivation ng formula ng tangential stress using those figures. Okay? So, derivation. Kasi, let's say, nakalimutan niyo yung formula na ito, at least, you know how to derive using these figures. Okay? Pwede ninyo makuha yung formula gamit ang figures na yan. So, again, sir, question. Sir, what if may pressure sa labas? Diba sabi natin kanina, yung pressure is nasa loob. So, what if may pressure sa labas? So, if may pressure sa labas, ang mangyayari sa formula natin, what is this? When there is pressure, outside, the formula would be sigma T is equal to internal pressure minus outside pressure times B over 2T. Gets ba? Ito lang yung nangyari. Yung P, ilagyan ng PI minus PO. Okay? So yan, yung formula ng tangential stress. Okay? Now, proceed tayo sa longitudinal stress. Yung sabi ko kanina, di ba? Sa tangential stress is yung effect ng pressure is circumferential. Gets? Epekto ng pressure is circumferential, meaning to say, yung circular. Sa longitudinal stress, epekto ng stress is elongation. Iya, pumimit niyan. So pressure ka na pumimit niyan. Okay? Yung kanina, dito, tangential stress is circumferential yung pressure. This time, dito, yung pressure natin is pag ganito. Kung gamitin niyan, present ano, in which makukuha siya ng elongation. So, as you can see, sabi ko rin na, kung gamitin sa yan, ito yung magiging itsura ng pressure natin. Diba? Of course, may thickness, may dalawa, tapos may dig dito. So, ito yung pressure, okay? Yan yung ibig sabihin ng longitudinal pressure. When there is pressure, obviously may force din na magaganap sa system natin or magkakaroon sa system natin. Now, same, kung i-derive natin yung formula, same lang din doon. Consider pressure, P is equal to force over area. So, force natin is equal to pressure times area. So, this time, ano yung area ng longitudinal stress or ng force na applied? So, force and pressure times this time, yung area natin is dito. Itong circle dito. Okay? Yeah, circle saya. So, you need to say, area ng circle is pi over 4 d squared. Right? So ito yung epekto ng force. Ito yung formula ng epekto ng force. Next, ano yung pressure? This time, epekto due to stress. Longitudinal stress is equal to, again, force over area. But force is equal to area, sigma L times area. But this time, ano yung area natin? Ano yung area natin, class? This time, sabi ko rin na, yung force na nabuo due to pressure is dito, right? Pero this time, since ang gina-analyze natin is yung stress, ang gina-analyze natin dito is yung stress, meaning dito sa material mismo, okay? So, since sa material, ay ano area, nag-giya, saya. Giya. Giya ni area tano. Meaning to say, ang magiging area natin is sigma L. So, mangyayari is sigma, okay, wala na timing, sigma L times pi d t. Okay? Ito, pi d times yung thickness. Okay? So, ito yung force dito, equate natin sila. So, P times pi over 4 d squared equals to sigma L times pi d t. Tingnan natin yung value ng sigma L. Sigma L is equal to P pi over 4 d squared over pi d t. Gets? As you can see, may pi sa taas, may pi sa baba. So, pwede natin i-cancel ito. Dalawang b sa taas, isang b sa baba. Pwede natin i-cancel yan. So, all we have now is p d over 4t. So, tingnan yung handouts. Ito yung formula ng longitudinal stress. Okay? So, that is all for the concept behind longitudinal stress at saka yung derivation ng formula. Take note, if makalimutan yung formula, pwede kayo na lang yung mag-derive ng formulas. Okay? By using these figures. So again, this is the third video. Next video, which happened to be the last video, is the examples. Examples ng what is this? Thin-walled pressure vessels. Again, if may tanong kayo, comment lang sa comment section. Tapos, make sure to include your name. And again, I highly encourage paki-print yung materials para mas klaro yung discussion natin. So that's all for this video. Thank you.